Hello, this is Max, working on problem 3B from fall 2014 final exam. And in this problem, it sort of builds on the previous problem, so if you haven't taken a look at that, go back and watch that video. So our TA suggests an alternative representation of an expression in which the entry is the value of the expression. For combinations, the operator appears in the leftmost index 0 branch as a leaf. That means a tree as well. This question was updated from its original published version, which had a flaw in the provided code. Alright, implement transform, which takes an expression and mutates all combinations so that their entries are values and their first branches are operators. In addition, transform should return the value of its argument. You may use the calc_apply function defined below. Okay, so given something like this, which is an expression tree that we had from our previous problem, we want to sort of evaluate what the value of this expression is, and then place it at the root of our tree. And for each of our sub-expressions, do the same thing, right? So evaluate what the sub-expression is, place it at the root of our tree, and move our operator down from being the head of our tree, the entry of our tree, into the very first branch of our tree as a tree. Okay. All right, so implement transform, we're going to do that. So calc_apply, if you remember, is just going to, this essentially looks like is just going to take, depending on what our operator is, so what our string operator is, it's going to do whatever the operation that corresponds to it is. So if I give it a list of arguments and I'm supposed to sum them together, it's going to do that and sum them together. Okay, product does what products do. Looks like we have access to multiplication again. That's fine. Okay, so let's take a look at our two trees. So transform an expression tree to have the tree entries and operator leaves. All right, so transform, first off, transform is actually returning the operator or the evaluated expression. So it's returning an integer or some float or whatever, and is not returning the tree itself. It's just modifying the tree that we pass in. So we're passing in 7, and we're going to get the number 7 out, and we're going to, when we look at 7 again, the tree, we're going to actually see a tree that's been modified. So that's important to note as well. All right, so I'm passing in some tree, t.entry in, so it's looking at each of, so if our entry is one of these two, so it's actually an operator that's going to have some subtrees, what do I want to do? For b and t.branches, args.append something, and t.branches. So here I'm doing the modification, right? And t.entry, I want to be the value of whatever I've evaluated things to be. And the way I'm going to get the value of things out is I'm going to, so let's see what else happens. Okay, so transform. So the way I need to get the value of each of my subtrees, right? And then I'm going to, so get the value of each of my subtrees out, and then I'm going to apply the, apply whatever is in my entry currently to each of my subtrees. All right, so I'm going to args.append. And let's say that transform, we know that transform is going to return the value of one of our trees, right? So we're going to say that args is going to be a way for us to keep track of all of the arguments that we're eventually going to want to pipe into calc_apply. And why do we want to pipe something into calc_apply? So what we're doing is we really want to get the value of this tree, right? Get the value of this tree, and then get the value of any of the other branches that I have, and then I want to add them all together. And calc_apply is going to take whatever string I currently have as the head of my tree, and I'm going to add up a list of arguments that I give it. If I'm a plus and if I'm a multiplication, I'm going to take the product of some list of arguments and I'm going to give it. But I need to construct that list of arguments, and the way I'm going to do that is by calling transform. So I'm looking at each of my branches, and I actually want to transform my branch. And the reason I want to transform my branch is because I know transform is going to return the value of the tree. Okay, and so now we're going to collect the values of each of our branches. And then for t.entry, here we're able to actually say, okay, well I want my branch to be the, I want my entry to actually be the value of the tree that I'm looking at. All right, so that's fine. But I think first, in order to do this, we're going to need to hide our branch inside of our operator inside of our first branch right here. All right, so let's take a look at how we're going to do that. So let's take our current entry. So we need to turn our current entry into a tree, because it's going to be a branch. And now I am essentially just taking my previous list of branches, which are now transformed, right? And I just want to take this previous list of branches and add into its very front my tree.entry. So I know that branches is a list of trees, so I can do this right here, and that's going to work fine. Okay, and so now now this should be fine as well. My t.entry is going to be that, and so I'm going to do calc apply here to get the value. The t.entry. So t.entry here is still the string plus, and I just added an extra branch here at the beginning. And so now I need to actually use calc apply to figure out what the value of my entry should be, because I want to replace the string that I had previously as my head with the actual value of my evaluated tree. Okay, so I'm going to do calc apply t.entry, and I've just created a list of arguments, so I'll just pass in args right here. Okay, and so now this handles the case where I'm actually doing something because I have a nested expression, right? So I either have a multiplication sign or a plus sign as my head. If neither of those is the case, then all I want to do is return t.entry because it must be some integer. Okay, so if you have any questions about this, please feel free to leave a comment on YouTube or on Piazza, and if you spot any problems with this, please let me know and I'll fix them. Thank you.